Sorry, this will be another video just because as the video was paused, my calculator is broken. I'm hitting on and it's just not working. And the batteries are all in, they're all fine. The batteries are new and it's just not turning on. And I'm so disappointed. Here, let's see if I take a battery out and I go and I plug it back in. Oh, it's working now. Oh, that is so cool. Okay, never mind. I guess it's working now. Maybe it's just like possessed or something. It was doing like weird demonic things. So I'll just let it sit there and collect dust. Okay. So here's the deal. Just did a couple. That's funny. Alright, so did a few conversions. I went from manganese to manganese oxide. Is that focusing? I don't know. Well, manganese to manganese oxide. I got 24.4 grams. And here went from oxygen to manganese oxide. Got 39.5 grams. Oh, now it's focusing. Cool. Alright, so based on all this, let's get a new color. It's a green one. Based on all this, the theoretical yield of manganese oxide is whatever one is less. Because according to this, once I use 17 grams of manganese, I make that much manganese oxide, which means the manganese is gone. So there's no more manganese. Because I can't make 39.5, because once I make 24.4, which is lower, manganese is gone. So to answer my first question, it's actually this one. So this equals my theoretical yield of manganese oxide, which also means my limiting reactant, there we go, is manganese. Which means my excess reactant is oxygen. So theoretical yield is 24.4 grams of the product. The limiting reactant is manganese. And finally, we got to calculate the amount of excess reactant remaining. Cool. There are a few ways to do this. The quote-unquote simple way, which is 100% wrong, is to subtract these two masses. That's too easy, and it's also extremely wrong. That doesn't give you anything. So don't subtract the two masses. That's the easy way out, but it's also 100% wrong. The way to calculate excess reactant is just doing more stoic. You have to do one more gram to gram conversion. What I'm going to do is convert all of this into oxygen to see how much I actually used. You can do that. Everything in this reaction is able to be converted. I mean, given this amount, I could convert it. I just did convert it into mass of the product that I created. Now I can convert it into mass of the other reactant that I can use up. So let's do that down here. I'm going to pause it. Alright, so I did a little conversion here. From 17 grams of manganese all the way into grams of oxygen used up. So what I get after doing all this math is that this much oxygen has been used up. How do I know that? Well, everything in this reaction is related through the mole ratios, through the balanced equation. So if according to me, if I use up all 17 grams of manganese, and if I make that many grams of manganese oxide, I must have used up also 7.43 grams of oxygen. Therefore, if I used up that much, how much is remaining? Well, I started with that, and I used up that. Let's harness the power of minusing. If I do 12.0, it's hard to write. Minus 7.43 with my hopefully non-possessed calculator. Oh man. 12.0 minus 7.43. I will get 4.6 grams of O2 remaining. And that's with sig figs, yes. So 4.6 grams of O2 remaining. So that means I can put more manganese in this reaction vessel or whatever it is and make more of the manganese oxide. Alright, that's it. Thanks for watching.